Welcome students. Today our topic is quadratic equations. Now first we start with polynomial. Now what is the definition of polynomial? Suppose f(x) equal a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 up to an, where a naught, a1, a2 are the constant and which belongs to the real number, and x is a real variable, and one more important thing, a naught should not be equals to 0. Now a naught, a1, a2 are the real constant and x is a real variable. Now we shall discuss the first constant polynomial. What is constant polynomial? When f(x) equals to a naught and this a naught is not equals to 0 and a naught belongs to any real number r. So f(x) is a constant polynomial. For example, f(x) equals to 2 is a constant polynomial, f(x) equals to 3 is also an example of constant polynomial, and we can take the several example of constant polynomial. Now a naught, if a naught equals to 0, then f(x) will be 0, that is called 0 polynomial because the constant part is 0. Now we will discuss the linear polynomial. It is clear from the name of the polynomial because highest power in that polynomial is 1, a naught x to the power 1 plus a1. A naught should not be equals to 0 because in this the highest power should not be equals to 0. A naught is not equals to 0, so this polynomial is called linear polynomial. For example, f(x) equals to 2x plus 3 is example of linear polynomial. Here a naught is 2 which cannot be 0. Now we will discuss the degree of the polynomial. What is the degree of polynomial? What is the degree of the polynomial? Here the polynomial in the definition, f(x) equals to a naught x to the power n, a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus an up to an. A naught should not be equals to 0. So the coefficient of highest power is not equals to 0. So here the highest power is n, here the power of variable is n, so that is why the degree of that polynomial is n. Now suppose f(x) equal a naught x square plus a1x plus a2 is a polynomial of degree 2. It is called quadratic polynomial. We can take several example of quadratic polynomial. Suppose f(x) equals to 2x square minus 3. Here the a naught is 2 which is not equals to 0, and a1 is 0 and a2 is minus 3. We can write in that way, 0x 2x square plus 0x minus 3. a0 is 2, which is not equal to 0, and a1 is 0, a2 is minus 3, because the highest power in that polynomial is 2, so that is why it is called quadratic polynomial. Now we shall discuss the cubic polynomial. Cubic polynomial, if f(x) equals to a0 x cube plus a1 x square plus a2 x plus a3, and a0 should not be equal to 0, because I am saying that the coefficient of highest power should not be equal to 0. Here the highest power is 3, because it is a cubic polynomial, that should not be equal to 0. For example, f(x) equal 2x cube plus 3 is an example of cubic polynomial. Now we shall discuss the y quadratic polynomial. Y quadratic polynomial, the polynomial which can be expressed in the form of a0 x to the power 4 plus a1 x cube plus a2 x square plus a3x plus a4, and a0 should not be equals to 0. Now we shall discuss the polynomial equation. What is polynomial equations? Suppose f(x) is a polynomial, that is your polynomial, and f(x) equals to 0, that is called polynomial equation. Same example, suppose if we want to write a linear equation, then it is 2x plus 3 equals to 0. It is the example of linear equation. Now the example of quadratic equation, 2x square plus 3x plus 7 equals to 0, because f(x) equal 2x square plus 3x plus 7 and it is 0. So that is why it is called quadratic equation. It is called quadratic equation. And the first example is linear equation. Now we shall discuss the quadratic equation. Quadratic equation is a0 x square plus a1x plus a2 equals to 0. a0 should not be equals to 0. And now first of all we will find out the roots of the quadratic equation. Now question arises, what are the roots of the quadratic equation and what are the possible roots of the quadratic equation? Roots of quadratic equation. Suppose f(x) equal ax square plus vx plus c equals to 0 is a quadratic equation. Suppose fx is a quadratic polynomial and it is equal to 0. Suppose a value of variable which satisfy the equation, the value of variable which satisfy the equation is called the root of the equation. If for any value of x which is alpha satisfy the equation, it is called the root of the equation. Let us take the example. Suppose x square minus 3x plus 2 equals to 0 is a quadratic equation. If we put x equal 1 in LHS, it will be 1 square minus 3 plus 2. It is 0. So, LHS is equal to RHS. It means x equal 1 will be the root of the equation. Now, the question arises, how many roots are possible in the quadratic equation? Suppose 2x square plus 3x plus 7 is a quadratic equation. So, maximum possible roots of this quadratic equation will be 2, because the highest power of x is 2. So, that is why the possible roots of the quadratic equation will be 2. Now, we shall discuss the roots of quadratic equation. Roots of quadratic equation with real coefficient. Suppose ax square plus bx plus c equals 0 is our quadratic equation, and a, b, c belongs to a real number r. Here we shall find out the root of the equation by using completing square. Now, divide the whole equation by a. Now, it will become x square plus b by ax plus c by a equal 0. It can be written as x square plus 2 x b upon 2a plus c upon a equal 0. Now, x square plus 2 x b over 2a by adding b over 2a to the whole square and subtracting b over 2a to the whole square plus c over a equal 0. Now, it is the formula of a plus b to the whole square. It can be written as x plus b over 2a to the whole square. Now, b square over 4a square plus c over a equal 0. Now, x plus b over 2a to the whole square equal v square over 4a square minus c over a. Now, take the LCM in RHS. Now, RHS will be, now the equation will be x plus v over 2a to the whole square equal 4a square v square minus 4ac. Now it will be, now taking the square root, it will be plus minus under root b square minus 4ac over 2a. X equal minus b upon 2a plus minus under root b square minus 4ac over 2a. Now take the LCM. Now it will be x equal minus b plus minus under root b square minus 4ac. Now as I have told, there will be two roots of the equation. If we will take the positive sign, you will find the first root. If you will take the negative sign, you will find the second root. Now the roots will be, suppose alpha and beta are the roots. Now the roots will be alpha equal minus b plus under root b square minus 4ac over 2a, and the second root is beta equal minus b plus minus under root b square minus 4ac over 2a. That is the second root. Now after finding out the root, we will discuss the nature of the root, whether it will be real, whether it will be imaginary, or whether it will be distinct or same. So now without finding the roots, we can find out the nature of the root, nature of roots of a quadratic equation. Suppose ax square plus bx plus c equals 0 is our quadratic equation. Now we shall discuss the nature of the root, because if we are finding the roots, that x equal minus b plus minus under root b square minus 4ac over 2a. Here the d equal, that is called the discriminant in the root, discriminant d equal b square minus 4ac. The nature of the root will depend upon the discriminant of the root, the value of the discriminant. What is the value of discriminant? If d is positive, negative or 0, we can find out the nature of the root. Now let us talk about the value of the discriminant. If this value d is greater than 0, means the value of b square minus 4ac is greater than 0. How can you tell about that? If we find that the value of d is greater than 0, here the square, in this the square root will be positive, that the value of d is greater than 0. So the root will be real and distinct. Because if you find d greater than 0, then you will take positive sign, you will get the first root. If you will put negative sign, then you will get the second root, and the value will be real. Now if d is less than 0, means b square minus 4ac is less than 0, this part will be negative, b square minus 4ac is negative. So the value of x will be imaginary. So the roots will be, imaginary. If d equals 0, suppose the value of d is 0, in that case the roots will be real and same. Now the relation between the roots and the coefficient of the equations. Relation between roots and coefficient of equation. Suppose fx is a quadratic polynomial which can be written as fx equal ax square plus bx plus c, and if it is a quadratic equation then fx must be 0. It means ax square plus bx plus c equal 0 is a quadratic equation. Now the roots of this equation will be alpha and beta, because there will be two possible roots of the equation. So that is why the roots of the equation are alpha and beta. Suppose alpha and beta are the roots of the equation. So the value of fx will be ax minus alpha x minus beta, because the coefficient of x square is a. Now ax square plus bx plus c equal a x minus alpha x minus beta. Now if we will multiply in RHS, it will be x square minus alpha x minus beta x plus alpha beta. Now ax square plus bx plus c equal ax square minus a alpha plus beta of x plus a alpha beta. Let us compare the coefficient of x square. Coefficient of x square. Here the coefficient of x square is a, and here the coefficient of x square is a. Both are the same. Now coefficient of x. What is the coefficient of x? The coefficient of x is, here in LHS it is v, and here in RHS it is minus a alpha plus beta. Can we find out the value of alpha plus beta? We just do the transportation and we get alpha plus beta equal minus v over a. Let us compare the constant part. Here the constant part is in LHS is c, and in RHS it is a alpha beta. Let us compare the constant. What are the value? It is c and it is a alpha beta. The value of alpha beta equal c over a. Now alpha plus beta equal minus b over a, alpha beta equal c over a. Now start the discussing the first relation between roots and the coefficient of equation. As I have told you that fx equal ax square plus bx plus c is a quadratic polynomial. If fx equals to 0, it is ax square plus bx plus c equal 0, and alpha and beta are the roots of the equation. Now you have determined the value of alpha plus beta, which is minus b over a, and alpha beta equal c over a. The alpha plus beta is sum of the roots and it is minus b over a. It can be written as minus coefficient of x over coefficient of x square, and in the product of the root, it is coefficient of constant part and it is coefficient of x square. Rather than say coefficient of constant part, it can be said the constant part and divided by coefficient of x square. So now we shall discuss some problem based on these topics. Let us discuss the first example. Find the harmonic mean. HM means harmonic means, as you have studied in earlier classes. Find the harmonic mean of the roots of the equation 5 plus root 2 x square minus 4 plus root 5 x plus 8 plus 2 root 5 equal 0. That is the quadratic equation because a naught is not equals to 0. And suppose alpha and beta are the roots of the equation. And the given equation is, given quadratic equation is 5 plus root 2 x square minus 4 plus root 5 x plus 8 plus 2 root 5 equal 0. Now we can find out the sum of the roots of this equation and product of the roots of the equation. Then we will find out the harmonic mean of the roots. Now alpha plus beta, here the alpha plus beta equal minus b over a, means coefficient of x over coefficient of, here we find the coefficient of x is minus 4 plus root 5. Now we shall put the value of it is minus 4 plus root 5. Now it will be plus 4 root 5 and the coefficient of x square is 5 plus root 2. That is the value of alpha plus beta. Now we shall find out the product of the root, which is c over a, means constant part over coefficient of x square. Now the value of alpha beta, the constant part is 8 plus 2 root 5. There is no variable involved with 8 plus 2 root 5. So alpha beta is 8 plus 2 root 5 over 5 plus root 2. Now we shall discuss the harmonic mean of these two roots, because harmonic mean is h of the roots alpha and beta. H is the harmonic mean of alpha and beta. So alpha, h and beta are in HP. Now you know that 1 over alpha, 1 over h and 1 over beta means reciprocal of the numbers will be in AP. Now from the result of AP, twice of mid number, twice of h equal 1 over alpha plus 1 over beta. Now 2 over h equal alpha beta over beta plus alpha. What is the value of h? H equal 2 alpha beta over alpha plus beta. As you have already found out the value of alpha beta and alpha plus beta. The alpha plus beta is 4 plus root 5 over 5 plus root 2, and alpha beta is 8 plus 2 root 5 over 5 plus root 2. Now put the value of alpha beta and alpha plus beta in that. It will be h equal to, the value of alpha beta is 8 plus 2 root 5 over 5 plus root 2, and the value of alpha plus beta is 4 plus root 5 over 5 plus root 2. Take the common in that. 2 to the 4, and it is 4 plus root 5 divided by 5 plus root 2. Let us take the reciprocal of that. 5 plus root 2 divided by 4 plus root 5. This go with this and this go with this. The value of the harmonic mean is 4. Now let us move on to the next problem. The second problem is, find the maximum and minimum value of this expression. What will be the maximum value and what will be the minimum value of this expression? The expression is x square plus 14x plus 9 divided by x square plus 2x plus 3. Suppose the value of this expression is y. Let y equal x square plus 14x plus 9 divided by x square plus 2x plus 3. By multiplying, you will get cross multiplication yx square plus 2yx plus 3y equal x square plus 14x plus 9. Now do the transportation. Yx square plus 2yx plus 3y minus x square minus 14x minus 9 equal 0. Take the common in between two numbers. It is x square y minus 1, and if we will take the common in between 2yx and minus 14x, it will be 2 y minus 7 of x, and it will be 3y minus 9. Now this is the quadratic equation in x, and the coefficient of x square is y minus 1, and the coefficient of x is y minus 7, and the constant part is 3y minus 9 equal 0. Because the roots of this equation will be real. Roots will be real in two conditions. Either discriminant will be greater than 0 or discriminant will be 0, because the value of, for real value of x, the discriminant must be greater than or equals to 0. Now the formula for discriminant is d equal b square minus 4ac. Now the value of b square minus 4ac should be greater than equals to 0. Here the value of a is y minus 1, and the value of b is 2y minus 7, and the value of c is 3y minus 9. Now, we shall put the value of a, b and c in this equation. 4 y to the power y minus 7 to the whole square minus 4 y minus 1 and 3y minus 9 is greater than or equals to 0. Take the common and expanding the square, y square plus 49 minus 14 y, and it is 3y square minus 9y minus 3y plus 9 greater than or equals to 0. Now, 4 y square plus 49 minus 14y, now it is 3y square minus 12y plus 9 is greater than or equals to 0. Now, y square minus 14y plus 49 minus 3y square plus 12y minus 9 greater than or equals to 0. It will be minus 2y square minus 2y plus 40 equals to greater than or equals to 0. Now, we are taking minus 2 y square plus y minus 20 is greater than or equals to 0. Y square minus y. Now, y square minus y square plus y minus 20 is greater than or equals to 0. If we divide by the 2, then it will be minus y square plus 5y, splitting of middle term. We are factorizing this one, y square plus 5y minus 4y minus 20 greater than or equals to 0. Now, if we transport this negative sign in RHS, the inequality will be changed and it will be y of y minus 5 minus y plus 5 and minus 4 y plus 5 less than or equals to 0, and it will be y plus 5 and y minus 4 is less than or equals to 0. Now, y plus 5 and y minus 4, the product of y plus 5 and y minus 4 is less than or equals to 0. It will be 0 in two conditions, either y plus 5 is greater than 0 and y minus 4 is less than 0. If y plus 5 is greater than 0, it will be positive, and y minus 4 is less than 0, it will be negative, and the product will be negative. Now, it is also 0, so it can be y plus 5 greater than or equals to 0 and y minus 4 is less than or equals to 0. Here the result is y is greater than minus 5 and y is less than or equals to 4. Now, it can be negative, the result will be negative if y plus 5 is less than or equals to 0, and y minus 4 is greater than or equals to 0. If it is negative and it will be positive, so product will be negative. Now, y is less than minus 5 and y is greater than 4. Now you got the two result. Here in the first result, y is greater than or equals to minus 5 and y is less than or equals to 4, that is your the first result. And in second result, y is less than or equals to minus 5 and y is greater than 4. Because y is less than minus 5 and y greater than 4 cannot happen in the same time. So the first result is y is greater than minus 5 and less than or equals to 4. It means the maximum value of y is 4 and minimum value of y is minus 5, and the value of y is means the expression, because we suppose the expression y equal x square plus 14x plus 9 x square plus 2x plus 3, because the value of y is greater than maximum value of y is 4. So the value of this expression will be maximum value of this expression will be 4 and the minimum value of this expression will be minus 5. Now let us discuss another problem. Both the roots of the equation x minus a x minus b plus x minus b x minus c and plus x minus c x minus a equals 0 are always positive, negative, real or imaginary. You have to just find out whether the rule will be positive, negative, real or imaginary of this above equation. Now let us start. The equation is x minus a x minus b plus x minus b x minus c plus x minus c x minus a equal 0. Now multiply these two, x square minus a plus b of x plus ab. Now multiply these two, x square minus b plus c of x plus bc. Now x square minus c plus a of x plus ca equal 0. Now it will be 3x square minus, now take out the x from these three, x a plus b plus b plus c plus c plus a. Now plus the constant part ab plus bc plus ca equal 0. Now the equation will be 3x square minus twice of a plus b plus c of x plus ab plus bc plus ca equal 0, because it is a quadratic equation of real value of x, means the value of x is now we shall discuss what is the value of d, whether the d will be positive, real or negative or imaginary. Now first of all we will determine the value of discriminant. Discriminant will be d equal b square minus 4ac. The value of b is this one, 2 bracket a plus b plus c to the whole square and minus 4. The value of a is 3 and c is ab plus bc plus ca. Now it is 4 a plus b plus c to the whole square minus 12 ab plus bc plus ca. Now expand this a plus b plus c to the whole square, it will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca minus 12 of ab plus bc plus ca. Now it will be d equal 4a square plus 4b square plus 4c square plus 8ab 8bc plus 8ca minus 12ab minus 12bc minus 12ca. Now d is 4 times of a square plus 4 times of b square plus 4 times of c square minus 4ab minus 4bc minus 4ca. Now let us take 2 as common, 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Now it can be written as a square plus b square minus 2ab and b square plus c square minus 2bc. Now c square plus a square minus 2ca. The value of d is 2 times of a minus b to the whole square plus b minus c to the whole square plus c minus a to the whole square, because the coefficient of this equation, here the value of ABC, the coefficient are real. So ABC will be real. So for any value of ABC which belongs to a real number R, D must be, this expression must be 2a minus b to the whole square and b minus c to the whole square plus c minus a to the whole square is greater than or equals to 0. For any value of ABC, it must be greater than or equal to 0. This is D, D is greater than or equals to 0. This will be the condition when discriminant will be either 0 or greater than 0, and discriminant will be greater than or equals to 0 means in both the cases where the discriminant is 0 or greater than 0, the roots will be real. So the roots of this equation will be real. Let us discuss another problem. If the roots of quadratic equation x square minus 4x minus log a base 3 equals 0 are real, then the least value of a. What will be the least value of this value of a? Here the equation x square minus 4x minus log a base 3 equal 0. This is a quadratic equation. Now we shall find out the discriminant. What will be the discriminant? Discriminant will be d equal b square minus 4ac. The value of b is minus 4 to the whole square and minus 4, the value of a is 1 and the value of c is minus log a base 3. Now the value of d is 16 plus 4 log a base 3, because x belongs to real number, roots are real. So discriminant must be greater than or equal to 0. The value of discriminant is 16 plus 4 log a base 3 is greater than or equals to 0. For log a base 3 is greater than or equals to minus 16. Log a base 3 is greater than minus 4. Now, if we take in a power form, that it will be a is greater than 3 to the power minus 4, a is greater than or equals to 1 over 81, means the value of a is definitely greater than 1 over 81. Now, the minimum value of a is one over 81. In our next class, we shall discuss some more problems based on these concept. Thank you.